Hello and welcome to the last video on Introduction to Data. For this, we're going to be answering the question, what are some data collection principles and strategies used to obtain a useful data set? There's a lot of different strategies, and we're going to go into more in the next section, but there's two main topics, or two different types of data collection strategies that I want to go over and make sure that we understand before the next section. And those two are observational study and an experiment. So an observational study, we really should think about this as we're outside observers. We are looking at the world, and then we're collecting data in some way that does not interfere with what naturally occurs. So we're sending out a survey to a bunch of individuals to see what their thoughts on a particular issue are, or for them to detail how many hours they spend doing certain tasks during the day. We're looking at public or private data sets. So we're going to the US government, we're petitioning our local government officials to get data information. Or we work at a private company and we're collecting data about our product or about other internal systems. And we're looking at that to see how can we use this data to perform a statistical analysis. Or we're doing a cohort study. So we want to observe individuals over a period of time to see what we can learn about how they live their lives and how that impacts a certain outcome. Maybe it's a health outcome. So those are all different types of observational studies, or general types of observational studies, and they all provide insight from what naturally occurs or a naturally occurring phenomenon. So we're not interfering with what naturally occurs. We are observing what actually happens. We're finding associations between variables, and we're seeing what variables influence or associated with a specific outcome. Now, different from that is an experiment. So in an experiment, we are specifically assigning certain individuals to a test group and a placebo group. And so in the test group, let's imagine that we want to see how effective a new medicine is before we release it to the market. We have a test group who's given the actual medicine that's been developed by the pharmaceutical company. And in the control group, they're given just like a sugar pill. So a pill that does not provide any medical support or anything like that. So the people in the control group, we know, are not getting a medicine that will actually improve their health outcomes. So some people, depending on what disease it is or depending on what ailment it is, some people will naturally get better without any medicine. Some people will stay the same. Some people will get worse. So we want to see in our test group, is there actually a significant difference, a statistically significant difference between the outcomes of our test and our control group? In that situation, we look at the end result, the end outcomes, and then we're able to provide insight into a causal association. So we're either able to say that yes, providing this medicine did cause better health outcomes for patients, or we're going to say that there's not enough evidence to prove any causal relationship. Now, in an experiment versus an observational study, why are we able to kind of put forth this causal association when in an observational study we're not able to put forward that causal association? The main reason is because in an experiment we can control for a lot of these confounding variables. So we can make sure that our test samples all make sure they maybe all come from different regions, that we're not representing one region in one test sample, another region, and another test sample. We can make sure that we're stratifying our samples so that maybe all the people who exercise and eat healthy are in one sample, and all the people that don't exercise and don't eat healthy are in a different sample, so that because there's going to be a lot of different confounding variables that impact health outcomes. So we want to control for all those variables as much as we can. So in an experiment, we can really tone it in or hone it in so that the only difference between the test and control groups is that one gets the medicine and one does not get the medicine. Now, it's actually really important that the control group does not know that they are the control group. You have to make sure that every person in your experiment thinks they are the test group. So that's a really important component. But besides that, that's why we're able to really get at some causal relationships in an experiment and not an observational study. Because if we do the same thing in an observational study, we can look over a period of time and say that people that exercise more have better health outcomes, but it could be that people who exercise more have stronger social relationships, and those stronger social relationships is actually what reduces anxiety, which reduces stress, and that actually is the what improves health outcomes, and it's not exercise at all. So we can see those really strong relationships in an observational study and an experiment, but an experiment gets us to be more direct with what we say is causal and what we say is an association. Now, just stating that, I kind of want to flip back for a second on the next slide and go over the golden rule statistical studies, that an association does not equal causation. Just because we see a relationship in our data set does not mean that one causes the other. And that's not always a bad thing, so it's always good to understand our associations, but it will change how we present our effects. So if we're trying to predict health outcomes, we might say that exercise, diet, social relationships, those are all associated with better health outcomes, but we're not going to say that those necessarily cause better health outcomes, because maybe each one on its own doesn't provide a significant difference for health outcomes, but all of them together, or maybe two, if you have at least two, or you're at least a high performer in two of those variables, then you're going to have stronger health outcomes. There could be a lot of different variables that are impacting that there, so it's very difficult to really get at a true causality in statistics. We can say that something is statistically significant, that the association looks really strong and is most likely not there by chance, but at the end of the day, it's very hard to kind of prove causality in statistics. Now, there are certain things that we're gonna see and we're certainly gonna believe are causal, but you always want to consider this kind of golden rule whenever you're presenting information or kind of like concluding your analysis, because if you're going to use the word causal, you really want to be sure that what you are presenting as a causal relationship is truly a causal relationship. Now, just because association does not equal causation does not mean that we cannot find a causation. It just means that it's a very high bar to pass, and we want to be very, very clear with that. So with that note, that's the end of the first section. So thank you for watching these videos and coming through this with me. I'm really excited to get into the next section where we talk about sampling. And after that, we're going to start really doing some analysis work with data, and I think start doing some fun work. So I appreciate you taking the time. Looking forward to seeing you in class. All right. Thank you so much.